On the 12th day of Christmas, Mr. Ing gave to me 12 perfect scores, 11 lessons learning, 10 steps for factoring 9.
A7, domain and range, x and y intercept. And look at this one, we have something called a cube root. Before, if there was no number there, it was a 2, but now it's specifically telling us it's a 3. So these are called cube roots, okay? But we get to do the same exact thing. Change it to a y. Substitute in the y equals 0. Okay, so how do you get rid of this one? It's the same thing, but you see there is a 3, so we're going to have to put it to the power of 3. 0 times 0 times 0 is 0. You're going to see that these go away, including the radical sign. And then you're left with 4x divided by 4. X is equal to 0. Okay? You can double check by putting this in to your original problem to check for extraneous. 4 times 0 is 0. 3 identical numbers that multiply to be 0 is 0. And that does work. So you have 0, comma 0 as your x-intercept. Let's go ahead and graph that. Okay, let's get our y-intercept. Do the same thing, change it to a y. We're going to do substitution. Four times 0 is 0. The cube root of 0. Let me put this, show you guys on my calculator if you need help. So my graphing calculator, it is under math and then number 4. So you can just click down and then enter or press number 4 and then put a 0 in there. That's 0. Okay. So x is 0, y is 0. Look at that, it is the same. Okay, so how can you get something in here? You could pick some numbers in here, such as this, watch. Just do a x and y coordinate plane, okay, table of values. You gotta think strategically. I'm gonna have to eventually take the cube root. Okay, so if I put a 2 for x, 2 times 4 is 8. The cube root of 8 is 2. Remember, the opposite of that is 2 to the 3rd power is 8, which was in the inside, right? 2 times 4. Okay, so I have 2, that works. Okay, so what would happen, let's take a look at our graph. Okay, so again, I already have it math, this number, and we have 4x in there. 4x, and let's just graph it. Okay. Wow. This graph here looks like a what? That kind of looks like a cubic function. Oh. You guys should starting to make some connections. X to the 3rd, if you somehow solve it, its inverse is the cube root. Here's the question, how do you go from there to there? Oh, we switch the x's and y's, which will be a future lesson, but let's go ahead and get the domain and range here. Remember, fill in all the negatives if it helps you, and positive numbers. Domain, we go from left to right. So I have an arrow here, so that's negative infinity. And another arrow, positive infinity. Oh, interesting. That one had 2 arrows going left to right. Okay, let's try this one. Bottom to top, okay. Okay, the first thing you touch is always going to be, if you see an arrow, it's going to be an arrow. So there's an arrow and another arrow. So negative infinity to positive infinity. Look at that. Another one with two arrows, negative infinity to positive infinity. I think I see something for odd degree functions. All right, so let me highlight that. That is our domain and range. All right, A8, we have f of x equals the cube root of x minus 2. We're going to do the same thing. We're just going to change this to a y. You can start making some predictions. This minus 2 is in the inside. Back to our transformations. A future lesson. 0 equals the cube root of x minus 2. I want to get rid of this, so now pay attention. I'm going to have to do the power of 3. Why? These are opposites. Cube root and the power of 3 cancel, and you're just left with what's inside. So you're going to have 0 equals x minus 2. Add 2 to both sides. You're going to get 2 equals x. Okay? So, when x is 2, your y value is 0. Okay, so there is our x-intercept. Oh, interesting. It shifted over to the right. Instead of it being at the origin like the last problem, it's shifted over to the right. Add to x, go west. It's not adding to x, it's subtraction, so you go right to. All right, let's take a look at this one. Let's do the same thing. Change f of x to a y. Okay. Do our substitution. So I have 0 minus 2. So I have negative 2. Uh-oh. Can you find 3 identical numbers that multiply to be negative 2? Ooh, okay, for now, we're just going to do this, okay? This is my answer. X is 0. And you have the square root of, cube root, sorry, of negative 2. Okay? Let's graph it. See what happens. Math, cube root, x minus 2. Close parentheses, get out of there, and then graph it. Okay, it looks like a cube root. Rotated 90 degrees, flipped around about the y-axis, but this one shifted over what? 2 units. Okay, let's go ahead and sketch that. Question from the last problem, do you think the domain or range would change? Alright, let's think about this. Domain left to right. I have an arrow from here, negative infinity. Go towards the right. Positive numbers, positive infinity. Range, same thing. Negative infinity to positive infinity. Whoops. There it is. Again, is there a trick or a pattern you guys see about the domain and range? Well, if you have an arrow, 2 arrows, they're going to be this. Okay? Think back to a linear, think back to a quadratic. It's basically just a power. Looks like the power functions, right? We'll see you guys. Bye. We need to find x, y-intercept and the domain and range. Okay? Change the f of x to a y. I'm just going to do it on both sides. Save myself some time. Okay, we're going to take y equals 0. Use your highlighter, super helpful. Okay, remember this is not in the inside. So again, if you use my little chart PEMDAS and we're going backwards to solve, this is where we have to do this one first. Does that make sense? All right, add 5. That's 0. We're going to have to take the power of 3. Does that mean 5 times 3? No, that means 5 to the power of 3. So 5 times 5 times 5. Put in your calculator, you'll get 125. And you have x here. Okay? So when x is 125, the other part of the order pair is y equals 0. Okay? Pink, 125, comma 0. See, that's a good thing about having conceptual graphs or no number, like the little coordinates, the tick marks, because then you don't have to sit there and draw 125 of those. Does that make sense? All right. Let's do the same thing over here. This time is a little bit different. This is telling me make x equal to 0. Y equals 0 minus 5. The cube root of 0 is 0. Again, if you need help with that, look at your calculator, and 0 minus 5 is negative 5. So 0, comma, negative 5. Orange. Ooh. Look at this one. What do you think the graph's going to look like? Oh, look at this. This negative 5 is on the outside to the right. Looks like a D value. Looks like it's going where? Shifting what? Down. Let's double check. Math. Cube root. Okay, x. Okay, now go out, because that minus 5 is not there. Minus 5, not negative 5. So it looks kind of like the cubic root, the cubic function, but shifted down, or the inverse of it. I mean, that's at 125, so, but, all right, domain, left to right, arrow, and it's not negative because this is below. That's not the reason why. Again, it's the x values are negative. And the last thing is another arrow. Range bottom to top, same thing. Arrow, the last thing you touch, arrow. Negative infinity to positive infinity. In other courses, they would have called that like all real numbers and all real numbers. But we're using interval notation. I like it because it tells you a start and an end. So there's my domain and range for A9. Bye-bye. I have f of x equals the cube root of x divided by 4. Now, I actually like this one. Let's just say the problem was written like this. If I asked you to write a 1, where would you put the 1? You would write the 1 here. So in some ways, this is really 1/4 times the cube root of, sorry, that's an x. Okay? So let's do the same thing. We're going to change this to a y. Substitute y equals 0. Zero equals the cube root of x over 4. Okay, we're solving for x. You can use my little chart, PEMDAS, and we're going this direction to solve, so there's no addition and subtraction. This is division, divided by 4, so the opposite is multiplication. So I'm going to multiply both sides by 4. Okay, you have 4 times 0, which is 0. This one is 4 over 1, so these 4 divided by 4 is 1. You're left with the cube root, that's a 3, of x. And the next one is the square root, or cube root, and the opposite of that is to the third power. So you're going to get 0 equals x, and when x is equal to 0, our y value is 0. Or you could say when y is 0, x is 0. So you get that order pair. Remember, the question you should be thinking about is, what do you think is going to happen to our graph? And I'm kind of going opposite. We're doing the x and y intercepts first because we're kind of giving puzzle pieces to the graph and getting something about a graph, okay? Same thing, let's change that to a y. We're going to do our substitution here. Three identical numbers that multiply to be 0, that is 0. Can you divide it by 0? I mean, something divided, 0 divided by something? Yeah. And guys, this is like a common mistake for students. Put it in your calculator, okay? So easy to think 0 divided by 4 or 4 divided by 0 the same thing. They are not. So pay attention. Okay, when x is 0, y was 0, and that is our y-intercept. Let's put it on a graph here. Okay, just think back to our parent function. Question is, what do you think happened with that divided by 4? It's really your a value. Get a graph. I'll show you a trick the student taught me is you're gonna press alpha, then y equals. It gives you the fraction option, so then you can just press the math for x, press right to get out of underneath or the radicand, press down, and then 4, and then graph. It looks like it did some kind of vertical compression because it's your a value. Because they're just, whatever your answer is, you're just dividing it by 4. Okay? Alright, let's get our domain and range now. As I go from the left, first thing I'm touching is an arrow. Okay? Pay attention, this arrow is not referring here, we're talking about domain, which is the x-axis. So this is negative numbers to arrow positive numbers. Let me try something different. I'm always trying to show it to you a little bit differently, okay? Now, okay, negative, positive. Now we're going to refer to this darker blue line, okay? Nothing, nothing, nothing. I have an arrow. It's not referring to this, referring to bottom to top. So negative numbers touches to positive numbers touches. Okay, and remember, when you have two sets of arrows in both directions, you're always going to have that. So there is our domain and range here. F of x equals the cube root of negative 2x. Let's change it to a y. Substitute y equals 0. And then I'm going to solve for x here. You'll notice that there's nothing in front. That would be multiplication. Nothing below, that's division. Nothing over here, plus or minus. So we're going to do the opposite, which is the power of 3. 0 times 0 times 0 is 0. This 3 and the little 3, the index with the radical sign, cancels. You're left with negative 2x. There's multiplication, do the opposite. 0 divided by negative 2 is 0, and you have x. So when x is 0, y is 0. There it is on a graph. Let's do the same thing for the other one, for the y-intercept. You're going to make x equal to 0. I'm going to change that to a y. Let's do the substitution. Y equals negative 2 times 0 is 0. Cube root of 0 is 0. Again, feel free to use your calculator. Quit. Math. Put a 0 there. What's your answer? 0. X is 0, y is 0. Whoop, that's at the origin. Let's put it here. Question, what do you think that negative is doing to the graph? Well, think about this. If you pick something like, I don't know, negative 4. Just thinking of a number, so when I take the cube root, it's nice. -2 times -4 is +8. The cube root of 8, 3 identical numbers that multiply together to equal 8, the answer is 2. And that is nice because when you graph it, -4, 2, your graph's going to do something like this. Okay? So I think that graph is going to look like this. Okay? Let's take a look at it. Let's take a look at it. Math. Number 4, parentheses, because you have a bunch of stuff. Negative, okay, remember it's this button down here, and then 2x. Okay, close the parentheses, go right to get out, and then graph it. There's our graph. Okay? All right, domain goes from left to right. I'm going to write in all those infinity symbols. I think it's super helpful. Where does my pen touch the graph? Right there at the arrow. This arrow is saying that all the x values are going to come from are negative. You can pick a negative x value. So negative infinity. Always, always, always with infinity, it's going to be a parentheses, always. So I'm going from left to right, and the first thing I touch is another arrow, which is positive infinity. You don't need to write positive. Range. First thing I touch is this arrow right here, so that is negative numbers. So the answer can be a negative number, or the answer can be a positive number. That's the domain and range. F of x equals the cube root of 1 minus x. Let's change this one to a y. Okay, substitute it in. Raise it to the power 3. Remember, these out here, the 3 and the 3 with the radical sign cancel. You're left with what's inside, 1 minus x. Okay, pay attention here. Simple. I want x always to be positive when you're solving, so I'm just going to add x on this side. Think about that. X equals 1. So when x is 1, y is 0. There's my x-intercept. And remember, look at this one. That's to the right of the origin. So what do you think happened there? Let's write it a little bit differently on the y-intercept, and this should make sense to you. Remember in a previous problem, we changed the order. Totally okay. Commutative property of addition. And let's just say I wanted to factor out the negative. And I'm doing this again for a future lesson, but it's super helpful for you guys to see this. So if I factor out a negative, or -1 as your GCF, you're left with x minus 1. All right, you can distribute and check your answer there, okay? Why did I do that? You're going to see that this value is a negative, so it's probably going to reflect over the y-axis, and over here you're going to see a horizontal shift. It's not adding to x, it's subtracting, so you're not going left, you're going to go right 1 unit. And that already proved my point. Okay? Let's change that to a y. It's okay to work with something a little bit different. Substitute in our x equals 0. Let's just solve for y here. Remember, my substitution, I'm always putting in parentheses. It got to be super clean and organized. Okay, so you're going to you're simplifying here. Okay, you're not solving anything yet, and everything's already on. Y is already solved for, so you're just simplifying. So you can use PEMDAS. 0 minus 1 is -1. -1 times -1 is +1. The cube root of +1 is 1. So you're going to have 0, 1 as your answer. Okay? Let's do that in orange. 0, 1. So it went up 1 unit. That's Why did it do that? Well, we talked about how you already have that negative sign. So let's just work with the original. Let's pick a negative number that would work in here. Let's pick, remember, you have to think strategically. I want to pick an x value, so the opposite with the 1, you can easily find the cube root. So I'm going to pick -7. How did I get that number? Think about this. -7. 1 minus -7. That's 1 plus 7. 1 plus 7 is 8. Cube root of 8 is 2. So -7, 2 would be something I can graph. So I think the graph will look like this. Okay. And let's double check that on our calculator. Dun, 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 dun. Okay, you could pick any of them. You could pick the original. Let's just choose original. Parentheses 1 minus x. Close parentheses, right key, graph. Look at that. Look at that. Whoops, I forgot to, it's a cube root. Forgot its tail. Okay. What do we got? So I go, domain is left to right. Okay. You stop when it touches the graph. Okay, what's the first thing it's touching? It's touching a arrow. Arrow will always be a negative or positive infinity, always. So in this case, although it's above, we're focusing on the x-axis. These are negative numbers on the x, so that's negative infinity. Always use parentheses. Same thing over here. Doesn't matter that it's going down. Okay, this is the common mistake. Students will write negative infinity because they think it's going down. The answer is no. It's a positive infinity because you still have positive x values. What's the big deal? It basically says you can pick any number, positive or negative, to put into this original function, and you can get a cube root function. Okay. The range works the same. So you have negative numbers, positive numbers. And I chose again not to use the iPad so I can show you the silly pen trick. Bottom to top. It's nothing, 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 nothing. It touches a graph. It touches a what? Arrow. That's the big idea. Arrows are like negative infinity. Negative numbers. And remember, not because it's going that way is it negative. We're focusing on the y-axis, up and down. That's positive infinity. So my answer can be any negative number or a positive number. That is the domain and range of A12. See you guys.
Math is my favorite subject and a very challenging class. And if you